All right, when you are identifying a conic, you want to look at the squared terms. So in this case, my squared terms are 4x squared and 8y squared. If the coefficients in front of your squared terms are the same, you're looking at a circle. So if this was like 4x squared plus 4y squared, that's a circle. If they're different, you're looking at either an ellipse or a hyperbola. A parabola only has one square term, so the fact that there's two means it can't be that, okay? So this has got to be either an ellipse or a hyperbola. The difference between an ellipse and a hyperbola is a positive and a negative sign. Both of these are positive. If one of them was negative, then it would be a hyperbola, right? The hyperbola has a subtraction to it. So because they have different numbers in front, that means it's not a circle. Because they have two squared terms, that means it's not a parabola. So we're narrowed down to a 50-50. And then since they're both positive, we would pick B. This one is an ellipse. Anybody have questions on the first one? One of your multiple choice on your final looks like that. Okay, it might not be an ellipse, so don't assume that it's an ellipse, but it's the same format. Like, what conic is it? And then you pick. Okay. For the second one, it says, complete the square for the hyperbola. So this one you've got to do a little bit of work for. So when you're completing the square, the first thing you want to do is put your squared terms together with your x. So x with x, and then y with y. And then I'm going to take that 252 and I'm going to add it to the other side. So it's a minus 252, so it becomes a positive 252 over here. All right. Now what I'm going to do is I'm going to divide out the 9 because I can't complete the square with a 9x squared. It has to just be x squared. So I'm factoring out a 9 here. And I get x squared minus 4x because 36 divided by 9 is 4. All right? And then I'm going to complete the square here. What's that perfect square? 4. Half of 4 is 2. 2 squared is 4. All right? Now for this next one, I'm going to divide out a negative 16. It's got to be a negative 16 because I have to complete the square with a positive y. So we get negative 16 y squared, and then negative divided by a negative is going to give me a positive. And then I need to complete the square with that. What's my perfect square for that one? 9. 6 divided by 2 is 3. 3 squared is 9. All right. So now on the other side, I have a 252. But I'm going to add a 9 times 4, and I'm going to add a negative 16 times 9, right? So I'm adding the 9 in front times the 4 that I created with the perfect square, and the negative 16 times the 9. So let's see what we get for that. 252 plus 9 times 4 plus negative 16 times, 252 plus 9 times 4 plus negative 16. It was times 9, right? All right, so we get 144 when we get this other side of the equation. So it's 9 times x minus 2 squared, because what multiplies to 4 and adds to negative 4 is negative 2 and negative 2. Minus 16 y plus 3 squared, because what multiplies to 9 and adds to 6 is 3 and 3, equals 144 when we added all of those numbers together. And then my last step is going to be to make this equal 1. So I'm going to divide out the 144. And what I'm doing is checking this fraction. So it's 9 over 144 and 16 over 144. I'm reducing the coefficients. So this is x minus 2 squared over 9 over 44 was 1/16. Y plus 3 squared over 16 over 144 was 1/9 equals 1. And then I just have to see what that matches. It's either A or B. The difference between A and B is the -3 and the +3. So this one's going to be B. The reason it is a +3 and not a -3 is because when we divided out the -16, right, we had to divide out a -16 to make that a positive y. And the negative divided by the negative created a +6, which then in return had a +3. So the answer to this one is B. That one took a little bit more work. Typically, you want to make like an educated guess. The coefficients on the x and the y kind of like cross multiply for the most part. Doesn't always have to happen, but it happens a lot of the time. So if you're really stuck and you want to make an educated guess, see how the original x started with 9? The 9 will cross over to the y denominator. And the original y started with a 16. The 16 will cross over to the x denominator. So there's usually the leading coefficients of the square terms in the answer. So if you're trying to make a guess, I go with the ones that have the numbers from the original problem. Now that only narrows you down to a 50-50 guess, right? That would get you A or B. Still better than 25%. You're more likely to guess the right answer that way. So if you're guessing, go with these numbers as part of your answer. Everybody okay with that one? All right, and then the last one says, determine the direction of the parabola. Well, y squared tells me that it's going to go either left or right. X squared is a traditional parabola. So if I were to type like x squared into the calculator, it would be a U shape. So the fact that this is y squared means it's either going to be left or right. The negative here tells me that it's either going to be left or down, right? The negative says it's going to open in the negative direction. So what they have in common is the left, right? So I know it's going to be either left or right, but it's negative, so it's going to open in the negative direction. This is an open left parabola.
Wait, I see how the negative means maybe left or down, but how do you know if it's going to be left, like how do you know it's going to be left or right?
So the y is the squared. There are parabolas that have, this would be x on the left that's squared and y is on the right. So if it's the squared term is y, it's got to be left or right.
Okay.
And then the negative determines if it's the positive direction or the negative. So a y, or a, if I just switched the x and the y and kept everything else the same, this is down. Because this is up or down, and then that's the down. All right, so these are really similar. Doesn't mean they're the same, but it does mean they're similar to the questions that you will see on your test. There are 3 of them. That's it, from conics, no open-ended. Today and tomorrow, we're going to review what a majority of your final is. I wanted to hold off to the week of the final to do that. And the reason I'm doing it today and tomorrow is that's the last time I'm going to see the seniors. So I wanted to make sure you saw that in class. Okay? Most of the second half of the year has been trig. And so most of your final is trig. All right? So today we're going to do the trig with a calculator review. And tomorrow we'll do the trig without a calculator review. So the things that we did in this part of the unit. We did conversions, degrees to radians, radians to degrees. We did more than that. We did like double conversions too. But that's like, you're not going to see it on your final. Like, what you see in our review is the stuff that's going to be on the final. So you will have to do a conversion, degrees to radians or radians to degrees. I can draw an angle in standard position and find its reference angle. So I can tell you to graph 300 degrees. You can show me where that is, and you can create a triangle in that quadrant. Given a coordinate point, I can draw a reference triangle and find the 6 trig functions. So you would plot a coordinate point. It would fall in one of the 4 quadrants. And then from that quadrant, you draw a triangle and you find all the things. That's an open-ended. And then I can solve a trig equation. This is just solving an equation. So like how you solve 4x plus 2 equals 10, right? But solving that with a trig. So in your 10 workbooks on page 9, is trig with a calculator review. So we're going to start with conversions. Here's what you need to know. You can use either of these converters. You already know this. Pi is equal to 180 degrees. 2 pi is 360. You can use either of them when you're doing your conversions. I'm going to use this one because I'm doing math, right? And if I'm doing math, the smaller the number, the easier the math. So I'd rather use the smaller number conversion to make the number smaller. But the 2 pi and 360 will work too if you want to use that one, if that's easier for you to remember. So when you are doing a conversion, you are multiplying by what's called a conversion ratio, meaning a fraction. So I'm going to multiply this 315 by a fraction. In that fraction is going to be a pi and a 180. In this fraction is going to be a pi and 180. In this fraction is going to be a pi and 180. And in this fraction is going to be a pi and 180. It's just a matter of where does the pi and the 180 go. And that's going to change depending on what you're trying to convert. So in this problem, I want to convert degrees to radians. I don't want the degrees anymore. If you want the degrees to cancel out, you need to put a degree in the bottom. Top and bottom match, then they'll cancel out. So that means that the 180 goes in the bottom and the pi goes on the top. When you multiply fractions, you do not need common denominators. So I can just do this. And when you multiply fractions, you go straight across. So it's 315 times pi over 1 times 180. What I'm not going to do is type it in the calculator like that, because look what happens when I do 315 pi divided by 180. That's not in radians, okay? It's in decimal form. So what I'm going to do instead is I'm going to work with the rational part of this, which is the 315 divided by 180. I'm going to simplify that fraction, and I'm just going to leave the pi with it. So 315 divided by 180 is 7/4. And then the pi was up top, so the pi stays up top. So 315 degrees is 7 pi over 4. Think about why that makes sense. Remember we had this. This was 0 pi over 2, but we also called that like 0.5 pi. Pi or 1 pi. 3 pi over 2, and we called that like 1.5 pi. And then 2 pi. 315 is an angle in quadrant 4, right? It's just before 360. So I want a fraction that's somewhere between 1.5 and 2. And 7/4 is between 1.5 and 2, right? So keep in mind, you're looking at multiple choice answers. So if I give you a multiple choice question that's let's find 315, you should know that the fraction I'm looking for needs to be somewhere between 1.5 and 2. You should be able to eliminate some answers just knowing that, even if you forget how to convert. Okay, so just keep like these strategies in mind, like just some number sense. 315's got to be a fraction in quadrant 4. Quadrant 4 is between 1.5 and 2. So I can eliminate some answers that way. All right, so same idea for this next one. I've got 150 degrees, and I want to multiply that by my conversion ratio. Degrees is in the top, so degrees goes in the bottom. Same exact format here. And I'm multiplying straight across. When you multiply fractions, you don't need a common denominator. So it's 150 pi over 180. Before I do anything else, 150 is in what quadrant? 2. So what I know that a fraction in quadrant 2 is it needs to be a fraction between 1/2 and 1. So when I get my answer, I just want to make sure it's something between 1/2 and 1. So I'm going to do 150 divided by 180. Math, enter, enter. And 5/6 is between 1/2 and 1. It's 0.83. So that makes sense. So just kind of a way to check your work as you go. So this one's going to be 5/6, because 150 over 180 is 5/6, and then the pi will just stay in the top. So before we even start with the next one, 4pi/3 is an improper fraction. So think about this as 1 1/3 pi. Does that make sense? Or 1.33 repeating pi. So that gives me a little bit of number sense on what my answer should be. 1.33 pi should fall in what quadrant?
3.
Somewhere in quadrant 3, which means when I change this to degrees, it should be something between 180 and 270. So even if you don't forget how to do the conversion, you can look at your answers and narrow down your options between something in between 180 and 270. Does that make sense? All right, so how we actually do the conversion, we're going to multiply by a conversion ratio, but this time I want pi in the bottom since it's on the top here. So I'm going to flip my 180 and pi. All right, so I'm going to do the 4 times the 180. We got 720 pi over 3 pi. And what happens here is the pi's cancel out, because it's 4 pi times 180, 720 pi, 3 times pi, 3 pi, the pi's cancel out. And so I'm just doing 720 divided by 3. And I'm hoping that I get something between 180 and 270. 240 is between those. My answer is 240 degrees. What quadrant would pi over 7 fall in? Think of the fraction 1/7. Quadrant 1. So that means that this angle should be somewhere between 0 and 90 degrees. So if we're looking at options, you could probably eliminate half the options just knowing that. Then you have a better chance of guessing. All right, so if I'm doing this one, I am going to multiply by 180 over pi. So it becomes 180 pi over 7 pi. Pi times 180, 7 pi, 7 times pi. The pi's cancel out. So I'm just doing 180 divided by 7. And it should be something between 0 and 90. We'll call it 25.71. You can round it. 25.71 degrees. So you can use a little bit of unit circle number sense to get through these answers, but when you're actually converting, you're using your pi and your 180. All right, so the next thing we do is we still take that number sense, but now we're going to physically draw the angle out. So this is on the same page. 210 degrees. This is an angle that is in degrees. And I know that in degrees, this is 0, this is 90, this is 180, this is 270, and this is 360. So 210 is somewhere here. Right? Somewhere between 180 and 270 is 210. It doesn't have to be perfect. Just draw something in that quadrant. Okay? So what quadrant is that? Well, this is 1, this is 2, this is 3, this is 4. So this is quadrant 3. Then you have to make what's called the reference triangle. The hardest part about a reference triangle is remembering that it's the x-axis and not the y-axis that you're using. I'm not going to make the other leg of the triangle over here. I'm not going to drop a line here. It has to be the x-axis. So this is the reference triangle, okay? What I want to know is this angle right here. This angle in green is called the reference angle. What I know is that this in red is 210. So I went 180 and I got to this point, and then I went a little bit more. And that little bit more is that green angle. So how could I figure out what it is? What is it? Very good. I can do 210 minus 180. And then that makes that 30 degrees. Each quadrant has a different rule though, so it helps to see the picture, right? You're not always going to subtract 180. Let's look at the next one. The next one is 315. And it's in degrees. So it's somewhere between 270 and 360. So when I draw this picture, I'm going to draw something in quadrant 4. Doesn't matter where you draw it in quadrant 4. Just remember that the reference triangle is always with the x-axis. So I want to use the x-axis on that right-hand side. Here's my reference triangle. This angle in this corner is called my reference angle. Right? So this is in quadrant 1, 2, 3. This is called quadrant 4. It goes counterclockwise. And what I know is that I went a full 270 plus more, and then I almost complete the full circle, but I stopped. To complete the full circle, though, is that little green sliver. So how could I figure out what it is? Minus what? From what? 360 minus 350. 45 is my reference angle. That is a different rule than the previous one. So just know the rules change as the quadrants change.
So did you do 315 minus 270? Because I did 360 and then I did 270 something.
You can totally do that. Okay. Yep. All right, now it gets a little trickier in my opinion when this is in terms of pi, right? Because I think we can graph in degrees a lot easier. So when I'm thinking pi, I'm thinking 0, and this is pi over 2. 90 degrees is pi over 2. But you can think of that as 0.5 pi. This is pi, 180 degrees is equal to pi. You can think of that as 1 pi. This is 270 degrees. That's 3 pi over 2. You can think of that as 1.5 pi, and then 2 pi. So when I'm picturing 5/6 pi, it might have, you don't have a non-calculator part. So if you don't know what 5/6 is, you can look at it like this. 5/6 as a decimal is 0.83 pi. So I'm trying to figure out where 0.83 falls. Well, 0.83 is not between 0 and 0.5. 0.8 is bigger than 0.5, right? It's between 0.5 and 1. 0.83 is some decimal between a half and 1. So that tells me that this is going to be something in quadrant 2. I'm using the fraction, right? It's less than 1, but it's more than a half. That puts it in quadrant 2. All right? And then I'm going to draw my reference triangle. Just remember, it's got to be with the x-axis. And what I'm looking for is this angle. That's 5 pi over 6. So the 5 pi over 6 plus that little green slither makes 180 degrees. 180 degrees is how many radians? 1. So 5/6 plus what equals 1? How many more 6 do you need? 5/6 plus 1/6, right? That last slither is 1/6. If that doesn't make sense, we are doing 180 minus the reference angle, or the angle, right? But we can't use 180. We got to use pi minus 5 pi over 6. But when you are adding and subtracting fractions, you do need a common denominator. So give this a 6, which gives this a 6. 6 minus 5 is 1. This is pi over 6. A very good educated guess. Now, it does not always work. I'm telling you, it does not always work. But an educated guess would be, if this is multiple choice, definitely pick one of them that has the same denominator as the question. So we can eliminate some things. Like if one of the reference angles is pi over 3, that ain't your answer. It's going to have the same denominator as the angle. Okay, so that'll narrow down some options. It's not always going to be pi over 6 though. Okay, so like it sometimes might have a number in the top is what I mean. So don't think that it always is 1 over the number, but it should always have the same denominator. All right, last one, pi over 5. If you don't know what 1/5 is as a decimal, then just type it in your calculator. It's 0.2. So this is a fraction somewhere between 0 and 1/2. Which means that it is in quadrant 1. And so if I create my reference triangle with this x-axis, we like quadrant 1 answers because green is what I want and red is the same thing. Pi over 5 is the reference angle here. Quadrant 1, there's no work. It's just the same thing. Drawing the picture helps see it. You don't necessarily have to draw the picture though. Like if you know the quadrant rules, you can just go directly to the rule. You don't need to see the picture. I know like about half of us in this unit use the picture. Half of us use the rules. All right, given the information, decide the quadrant. So we learned this thing that says all students take Calc. And what it means is every single trig function that we know, all are positive in quadrant 1. In quadrant 2, only the s is positive. So that means that the sine is positive, but the cosine and tangent are negative. T means that in quadrant 3, only the tangent is positive, which means that the sine and cosine are negative. And in quadrant 4, only the cosine is positive, which means that the sine and tangent are negative. All right, so the first thing we're going to do is we're going to look at cosine is 4/5. So cosine theta is a positive number because 4/5 is a positive number. So I'm looking for the two places that cosine is positive. Cosine is positive in 1 and 4. So I know that my answer has to be either quadrant 1 or 4. Then I look at the second piece of information. Sine of theta is less than 0. What this is telling me is that the sine of theta is negative, because if the number is less than 0, then it's negative. So now I'm looking to figure out the two quadrants where sine is negative. Sine is positive in 1 and 2, which makes it negative in 3 and 4. And so my answer is where both of the answers occur, which is quadrant 4 for this one. You okay with that? All right, let's look at the next one. I'm not going to write all of it out. I'm just going to do the ASDC. All students take Calc. All right? So, tangent theta equals -4. I am saying that tangent of theta is negative because it's -4. So I know that tangent is positive here and here. All and T, which means it's negative here and here. The answer's got to be 2 or 4. All right? So then I go to the second piece of information. Cosecant theta is less than 0. If you forget what cosecant means, flip through your test. At some point in your test, those 6, remember how we had them written as like 6? And they were always next to each other. Find that part of the test because you'll have all of it and look at what's next to cosecant, okay? Cosecant pairs with sine. So this is saying that if cosecant's negative, then sine is negative too, right? They take the same symbol. So this is telling me that sine is negative. Well, sine is positive here and here. So it's negative here and here. So the answer is quadrant 4 then. All students take The first one is saying that sine of theta is negative 1/5. So it's saying that sine of theta is negative. Here's where it's positive. So the opposite is where it's negative. It's got to be either 3 or 4. Secant, if you're not sure what it is, flip through your test. Find it where it's in a group of 6. See what secant is next to. It's cosine, okay? It'll be next to cosine. So you'll see that. So this is saying that cosine of theta is greater than 0, which means it's positive. It's positive in 1 and 4. I think it's purely coincidence that the answer is 4 for all of these. That's not sarcasm. I actually truly think it's coincidence. So don't think like the test it's 4. Go through all students take calculus and pick. This is a really easy multiple choice question to create because there's 4 options. A is quadrant 1, B is quadrant 2, C is quadrant 3, D is quadrant 4. It's definitely going to be a multiple choice question. Alright? This, however, is a really nice open-ended question because it has so many pieces that it would be hard to make this a multiple choice. So you're going to see something similar to this on one of your open-ended questions. So here's what you do. You're going to graph the point negative 4, 5. So negative 4 is the x value. You're going to go to the left negative 4 and up 5. So if I were to graph negative 4, 5, it would be here. You're going to connect that point to the origin, which is 0, 0. This angle right here is called the standard angle. And I immediately know something about that standard angle just by plotting the point and having that angle fall in quadrant 2. What do I know about that angle? It's got to be less than 180 or more than 90. So I'm just going to make a note to myself. If I go through and I solve this problem and I don't get something between 90 and 180, something went wrong, right? So I'm just making that note, right? And then I'm going to create this reference triangle by using the x-axis. This is the reference angle. I'm going to have that in green. And that angle is always acute, meaning that it should be something between 0 and 90. And that's always true, no matter where I draw a reference triangle, a reference angle is always less than 90 degrees. All right, so let's think about what else we know about this. If I were to count the tick marks, there is 1, 2, 3, 4 here. And if I were to count the dashes up, the height of the triangle is vertical. Like this is x, this is y. This isn't y, it's on a diagonal. So the 5 is here. And the 4 is negative, and the 5 is positive. I'm getting that from the coordinate point, right? So I'm including the negative and the 5. Just know that that's not the diagonal, it's a vertical distance. How could I get the diagonal? Pythagorean theorem. This is a right triangle. So I can do negative 4 squared plus 5 squared equals c squared. Now just make sure if you're going to use the negative, you use the parentheses, because if you don't use parentheses around the negative, you will get that wrong. Alright, so we got 41 is my c squared, and I just want c, so 41's a prime number, I don't need to simplify that. So we got root 41 is the third side of the triangle. Does anybody have questions on how we got to that point? Now, on your test, it might be a coordinate point that's in quadrant 3, and both of the x and y values are negative. It might be something that's in quadrant 4. So this could all change. The picture could change based on these things. So you have to be able to plot a coordinate point. That's like middle school math, maybe? Might even be elementary school, right? So make sure you plot it in the right quadrant. That tells you a lot. Now that I plotted it, I have 2 of the 3 sides. 2 of the 3 sides are the coordinate point itself. Find the third side using Pythagorean theorem. So now, sine, cosine, and tangent come from so, right? So sine is opposite over hypotenuse. Opposite based on the green angle. Okay, so your reference angle is what you're referring to when you're using all these things. So opposite of the green angle is 5, and the hypotenuse is root 41. You gotta rationalize. You can't leave the root 41 in the bottom. So it's 5 root 41 over 41. Is it okay with that one? Now next to it is cosecant. Cosecant is the reciprocal of sine, meaning it's sine flipped. I'm not going to flip here, because if I flip here, I'm going to have to re-rationalize. I'm going to flip here so that I don't have to rationalize. I'm going to put the hypotenuse in the top and the opposite in the bottom. I'm flipping this fraction. It's opposite over hypotenuse, and then hypotenuse over opposite. I'm going to add that in. All right, so cosine is the AH, so this is adjacent over hypotenuse. Just keep in mind that the adjacent leg has a negative on it, and it needs to have a negative on it here too. It's not a 4, it's a negative 4 over root 41. And I'm going to skip the step where I show myself rationalizing this, because there's like no space here. But if I multiply the top and bottom by root 41, I end up there. So secant is hypotenuse over adjacent. Just flipping that. So the hypotenuse is root 41 over the adjacent is negative 3. And then tangent is opposite over adjacent. So the opposite leg was 5 and the adjacent leg was negative 4. And cotangent is adjacent over opposite. Negative 4 over 5. The ones on the right-hand side are the reciprocals of the one on the left-hand side. You're just flipping their fractions. Anybody remember how to find the reference angle? You definitely have to be in degree mode. Let me add that note. Okay.
And you just do inverse of tan over 5 over tan 4. Or just do 4.
Yes. I'm going to go inverse tan. Now, that's not to say you can't use inverse sine or inverse cosine. You totally can. But look how complicated those look. I'm going to go with the road of least resistance, right? 5/4 seems easier to type into the calculator. So I'm going to go with tangent. And I'm going to do a second tangent. And what happens when you hit second tangent is you get tangent inverse. When you do the tangent inverse, you are going to do 5/4. If you include the negative symbol, you are not going to get an angle between 0 and 90. I'll show you. So first things first, let's make sure we are in degree mode. My calculator is. I've got that highlighted. Okay? And when I go to do the tangent inverse of 5 over negative 4, that's not a reference angle, right? A reference angle has to be between 0 and 90. So what you do when you're doing a reference angle is you don't include the negative. A reference angle without a negative will put me in quadrant 1, an angle between 0 and 90. All right, so my reference angle, it's the same thing. This takes away the negative. All right, so my reference angle is 51.34 degrees. That's the green angle. I want the red angle. What's the relationship between the red and the green? They add together to make 180. So my standard angle plus 51.34 equals 180. So if I subtract the 51.34, then I'll get the standard. 128.66. because there's so many pieces to this problem, it would be really hard to make it a multiple choice. This is definitely going to be an open-ended. It covers a lot of the stuff that we learned. It covers drawing a reference triangle. It covers reference angles. It covers standard angles. It covers reciprocal trig. It's got a lot of parts, so it's a really good kind of summative question. What's up, Zara?
How many open-ended questions?
There are 3.
Oh, okay, that's not bad. So this is
So you got 1 out of the 3 so far.
Okay.
Okay. 2 out of the 3 would be a sine cosine table from your quiz that you just took.
The one I
Right.
just aced.
The one you just aced. You all
Oh.
aced, right? I think we got, like, almost all of us got an A, right? So that's 2 of the 3.
It had to be an
I have to look, but I have zeros filtered in for people who didn't take it yet, so then it looks lower. Didn't we do this? 98 is the average without the zero.
Oh, that was really
Look
good.
at us go. All right, so that's 2 out of the 3, right? So 1, 2, and then the third one we'll review tomorrow, which is like a non-calculator type problem. Like she'll have a calculator. Technically use it.
For the test, will the quiz that I have to take tomorrow, can I use my calculator?
You can, not on the quiz. On the final, you can.
Okay.
All right, and then the last type of question. Now, this is what the third open-ended will look like. The difference between these and your open-ended on your final is these answers are going to be kind of odd. The decimals will be weird. With a non-calculator one, they end up really nicely. Like my reference angle here is going to be like 36.25, right? But if it's a non-calculator question, my reference angle is going to be 30, 45, or 60. So that's the difference, right? The process is the same. So it's 3 open-ended. Now 3 open-ended, like, that's not one question, right? But I'm considering it to be one question, right? So 3 open-ended, take that as you will, okay? And then it is either 20 multiple choice or 24.
I'm a 25.
Somewhere between there, all right? So it's not bad. All right, so the last open-ended looks like the one that we're about to go over, but the reference angles we're gonna get are not gonna be clean. On your final, they'll be clean. Does that make sense? When I say clean, what that means? All right. So when you are solving a problem like this, the first thing you have to do is you have to get the trig function alone. I need to get the cosine of theta all by itself. So I just have to do some inverse operations. All right. Subtract 3. So I get 6 cosine theta equals 2 minus 3, which is negative 1. And then divide by 6. Cosine theta equals negative 1, 6. So step 1, isolate the cosine. Everybody okay with that part? Okay. Step 2, I like to now pick my quadrants because there's going to be 2 answers to this. And that's going to be based on this. Cosine theta is negative because negative 1/6. So cosine is positive in 1 and 4. So it's negative in 2 and 3, which tells me something about my final 2 answers. One of my final 2 answers is between 90 and 180. And the other one of my final 2 answers is between 180 and 270. So when we get to the very end, we can check that out. Are you okay with that? Now, for some of you, you like to draw a reference triangle. For others, you just can find the reference angle. So to find, well, you do the reference triangle after. So to find the reference angle, just like we did here. We did the tangent inverse of 5/4. We ignored the negative and we just did 5/4. We're going to do cosine inverse now of 1/6. We're going to ignore the negative just like we did before. Make sure your calculator is in degree mode. No negatives. The reason your calculator is going to be in degree mode is because the directions say for numbers 13 and 14 from 0 to 360. When we do number 15, we'll switch to radian mode because it says solve from 0 to 2 pi. All right, so it just depends on what the directions say. Alright, so I'm going to do the cosine inverse of 1/6, not negative 1/6. Because if I do negative 1/6, I will not get an angle between 0 and 90. And a reference angle is between 0 and 90. So when I do the cosine inverse of 1/6, I get an angle between 0 and 90. So I want to use the 80.41, we'll call it, as our reference angle. Don't use the negative. Now this is where our approach differs. Some of you will draw two triangles. One in quadrant 2, one in quadrant 3. Some of you will just go directly to the rules. It is totally a personal preference. Okay, so I'm going to draw a quadrant 2 and a quadrant 3 triangle. You don't have to do this part, all right? So if I draw a quadrant 2 triangle, something in quadrant 2, and here's this angle right here is the reference angle. So the green angle is 80 degrees-ish. Red plus green is 180. I have green. So I can subtract. Now, if you don't want to do it that way, you can just use the rule. In quadrant 2, I do 180 minus the reference angle. So I would do 180 minus the 80.41. 99.59 is answer 1. Answer 2 would be something in quadrant 3. So you could draw the triangle if you want. This is what you have. You can see 180 plus what I have is what I want. So it would be 180 plus the reference angle. You can use the image for that, or you can use the rule. 260.41 is my second answer. I knew that in the beginning, when I picked my two quadrants, I was going to get one answer between 90 and 180, and I did. And I was going to get one answer between 180 and 270, and I did. Right? So just like that kind of stuff. Check. Now, what's different about the second one is it's a reciprocal function. So the first thing I would do would be to get rid of this. And then what I need to do is change this. What does secant go with? Cosine. So I'm going to change this to cosine. And I'm going to flip it. So if secant theta is 8 over 1, then cosine of theta is 1 over 8. Cosine is positive 1 over 8. So I'm going to do quadrants 1 and 4 for my final answer because 1/8 is a positive fraction and not a negative one. If that was cosine theta is negative 1/8, then I'm going to pick 2 or 3. All right? So now, I'm going to find the reference angle by doing the cosine inverse of 1/8. And I'm still in degree mode because the directions say 13 and 14 is 0 to 360. All right, so my reference angle is 82.82. You don't have to do this part if you don't want to. I'm drawing a quadrant 1 and 4 triangle. You don't have to do that. Okay? Quadrant 1 and 4 triangles look like this. And we know these are 82. This is what I want. This is what I want. Quadrant 1's nice because quadrant 1 is the same. Reference equals standard. So my answer in quadrant 1 is 82.82. I don't have to do any work. In quadrant 4 though, the two angles together make a full rotation. So reference plus standard equals 360. So I'm gonna have to do 360 minus the reference angle to get my standard angle. Each quadrant has its own rule, they change. $277.18. Now can we go test taking strategy? If this were a multiple choice question, you're gonna have options, right? All you have to do is, you can't do it for secant, you do it here. Cosine theta is 1/8. So take what option A is. Let's say option A was 82.82. Do the cosine of 82.82 and see if it's really close to 1/8. Do the cosine of, what was it, 277.18. And see if it's close to 1/8. You can guess and check by typing them into your calculator. Just make sure you're in the right mode. If you are in the wrong mode, it won't work. Okay? This is a good strategy if it were open-ended, you just check your work. But if it's multiple choice, you can use it.
It's multiple choice because it's two answers.
There would always be two answers, yes. So if it's multiple choice and one of the answers is 1, cross that one off. Definitely not your answer. There's always two answers to these. We okay on that one? Now the last one, the only thing I'm gonna do different is I'm gonna change the mode in my calculator, which is gonna make my answers look funky because we're not working with degrees anymore. Degrees is what you're used to doing. So it just looks more similar to you, alright? So if we were to get the trig function alone, it would be tangent theta equals -3. We're still doing, and all students take calc for that. Just the same. Tangent is negative, so it would be these. I'm still finding the reference angle by doing the tangent inverse of 3. It's just, it's not going to be something between 0 and 90. It's going to be something between 0 and pi/2, which is a weird decimal. So your reference angle is going to be a weird decimal. So I'm switching my mode. So it's between 0 and 1.57 because now I'm in radians. So my reference angle is 1.25. And that's radians. You don't have to put a pi on that. I think a lot of you make the mistake of calling that 1.25 pi. It's not. It's just 1.25. All right, and then I would apply that to my two quadrants. So quadrant 2 and quadrant 4, I'm not gonna draw pictures. Quadrant 2 is 180 minus, but in this case it would be pi minus. And then in quadrant 4 it's 360 minus, so that's 2 pi minus. You're gonna get decimals for both of those answers. Time-wise, I'm not taking them on, but you guys get the idea, right? Actually, I will. Pi minus 1.25, 2 pi minus 1.25, 1.89 and 5.03. Process was identical. It's literally just a button in your calculator. All right. So tomorrow when you come in, I'll give you some practice on these, but if you want to do additional practice at home, 14 through 32 is this unit, the practice that we did today. There is an answer key for that on Canvas. So if you're doing it at home and you want to check your answers, you can check them on Canvas. When you come in tomorrow, we'll review the non-calculator part. It's a lot shorter. Okay, there's not as much in the non-calculator part. And then seniors, that'll be it.